Hello everyone. So in this video, we are going to learn how to construct a binary tree using a post-order traversal and pre-order traversal. In our previous video, we have discussed that a unique binary tree can be constructed if we are provided with two traversals. So if we have given with in-order traversal along with a pre-order traversal, this is one scenario, or we are given with in-order traversal and post-order traversal, then it is very easy to construct a unique binary tree. So one thing to note here that in order to construct a binary tree, we need a minimum two orders. Okay, means we need to get either in order pre-order or in order post-order. Means out of these two combination, in order is visible here, and because of in order, we are able to construct a unique binary tree. But let us talk about a situation when we don't have in order with us, but we have pre-order and we have post-order, and still we want to construct a binary tree. Now here we cannot guarantee to get a unique tree. So if we have a tree which is full, means all the nodes are having two childs, then it is sure that you can get a unique tree. But if we have a tree something like this, where some of the nodes are having only one child, then we cannot guarantee that we are going to get a unique tree. So let's say this is the actual tree, and for this we are provided with post order and pre-order, and by using these two order we are trying to get back this tree. So we cannot guarantee that you are uh, actually going to get the same tree because we have one child here. There's a possibility you can get or come up with this tree. This is the same which we are looking for, or you can come up with this kind of structure. So whenever we have one child for any node, we cannot guarantee that this node is having one child, this child is a left child or right child. So you need to make a guess while you proceed for constructing your tree. At any stage where a node is having one child, we need to make a guess and then proceed. So the conclusion is, if all the nodes are full, means all the nodes are having two child, then we are going to get a unique tree. But if any of the node is having one child, then we have to make a guess and then proceed. Okay, so let's understand why it is happening. For example, this is one tree A, B, and C. Now, if I am going to find out its pre-order, now pre-order is basically node left, right. So we have to print the node, we have to keep traversing towards left, and then we have to keep traversing towards right. And post order is left, right node. So if I go with this node left, right, then our sequence will be A. This is for here I'm writing here, and for this I'll write here. So node. So we start from the root node, we get A, and then we go to the left, we get B, then we get C. Okay. So this is the pre-order sequence. Now, if I talk about the post-order sequence, so we have to go left. So we start from here, we go left, we have to go left, we have to go left. There is nothing, means that there is no further node. We have to stop here, and then we have to go right. There is nothing right. Then we go to the root node. So this is C. Once this left is done, we are going to right. There is nothing right. Then we go to the root node. Similarly, we get CBA. So this is the post order traversal. So let me write like this. This is the post order traversal. This is the pre-order traversal for this tree. Now, if I make another tree which is not the same, now you can see this is having three nodes. This is also having three nodes, but the three are different. Now, if I going to find the pre-order for this tree, so pre-order means node left, right. So first you print node, and then there is nothing. So you go to right. Then we go to node, left is nothing, you go to right, So A, B, C will be the answer. And when we find a post order, so we go to the left, there is nothing left here. So you go to the right, and for this you are left, then right, and C. Now left is done, right is done. We go to the node B and A. So what is the observation that we see here? We see that we have two different trees, but the pre-order and the post-order is same for both the tree. Okay, now this is happening because it has one child. Node does not have both the child. Keeping this in mind, now we will uh, construct a binary tree using the two traversal orders, that is pre-order and post-order. So what kind of question may be asked regarding this topic? So it may be asked that post-order and pre-order sequences are given to you and you are asked to construct a binary tree. This is one thing. Or the two orders are given to you and you are asked to find the in order. Now in any case, in order can be only find out when you are aware about the actual tree. So first we have to construct the tree out of these two orders, and then once we have a tree, we can easily get in order. So post order is actually working with this left, right node. So node is basically here representing the root, and pre-order works with node, left, right. So I believe that you are aware about that how to traverse in the post-order way and how to traverse in the pre-order way. We already discussed the algorithm for these two traversing mechanism. Okay, so here you can see that in this post-order traversal, the last uh, element is basically representing the root node. So this is the root node in our tree. Similarly, if we look to the pre-order, this is going to be our root node. Now, we are now confirmed that A is going to be a root of our tree. And then this is, if you look at this, this is left, right node means out of the entire sequence, some of the elements, some of these values are referring as a part of left subtree and some of them are a right subtree. Similarly, this is root. Among this, all the sequences, some of them are the nodes of the left subtree and some of them are for the right subtree. Okay, so when we look at C, so definitely C is going to be a part of right because we have left right node. And if you look at C here, now this is C is here. Okay, so now right comes at the last. That means from here onwards, this is going to be a right for us. Okay, so you can see CFIJK. And here this is B. B is actually the next to the node is the left part. This is basically representing the element or a node of the left subtree. Now, if you look at the B here, that means this from here to here, this is part is left subtree. From here to here, it is a right subtree. So we have left right node. Similarly, if you look at here, this is all going to be a left subtree and then this is a right subtree. Okay, so let's proceed with this information. So we have confirmed that A is our root node. And what about the left and right subtree? So we know that the right part is consisting of I, K, J, F, C. I took this sequence from the post order part, and similarly, in this sequence, the series of nodes will be C, F, I, J, K. Now, one thing to always note that whatever the sequence you're writing, the last node of this sequence must match with the first node of the sequence because this works on left right node, this works on a node left right. So if any time you find that this is not matching, that means something is missed here. Okay, so now we have find out that C is going to be our root node here. Now, if you look at this, again, this works on left right node and this is node left right. So C already we have taken out as a root node. Now this is F. F is basically representing the node of a right subtree, and this is F here. Okay, so that means This entire thing is basically representing the right. Now, if you look at this, this is basically for the left. So here it comes out to be left. That means here it appears that this is a part of right. Here it appears it's a part of right, left. Actually, it means that C is having only one child, and we cannot confirm that this child is a left child or right child, but there is only one child existing. So either we can take that, we can assume that this is going to be a right child, then there is no left subtree. That means there is nothing for the left part. The entire is the right part. Similarly, we can assume that for this node left right, there is nothing for the left, and entire is for the right part. So we proceed by assuming that this C node is having only a right child. We don't have a left child here. Okay, so you can even proceed with assuming as a left child. As I said, that we have to make an kind of assumption that it has only one child. You can proceed with assuming as a left child or right child. So we assume that it has a right child. So now what is left with us? We are left with I, K, J, F, and this is F, I, J, K. So now F is going to be becoming our next node or a root of a subtree. Then we are J is here. J is basically for right. So this is basically, you can say, uh, right subtree, and I is this when means this is for the left subtree, this is right subtree, and this is again left subtree and right subtree. So we find out that for the F, this is node is going to be become a left subtree, and for the right subtree we have a JK here, we have KJ sequence, and we have JK. So we understood that this is going to become a root here. So J is going to become a root here, and now again we have one node is actually left here. So here we have to again assume that it may be a left child or right child. Let us take that, assume that this is a left child. You can also assume as a right child. Let us take as a left child. Because of this, we are actually not going to get a unique tree, because I am assuming that this is a left child. You might be assuming it's right child. So the tree that we are getting out of these sequences are different. So that that actually is responsible for not making us to get the unique tree. Now, so we have already done with the right subtree. Now let us expand for the left part. So here, what we have left with, we are having here G L H D E B, and here we have B D B D G H L E. Let us make me some this darker. Okay. Now here you can see that this is going to be a root node. This is going to be a root node. So B is going to be a root for us. Now what is left with us? Now E is here, which is basically representing a part of right subtree. So if you look at this E here, okay, so this is basically for the right, and D is here. So D is here, that means this all is left part. This is the right part. So we have left right node. This is going to become a node left right. So okay, so we are we have we got it that right is only E. So right is only E, and in the left we have to again identify that how it is expanding. So in the left part we have G L H D, and we have D G H L. Just keep in mind that the last of this sequence must be matching with the first of this sequence. So D is going to become our root node here, and then H is here. That means this is going to be become right, this is left, and G. So this is actually the right part, and this is left. Okay, so we understood that L is the left child of this, and then sorry, not L. This is the left child, means G is the left child, and for the right we have to find out So for the right, we have LH sequence in the post order and HL sequence in the pre-order. So H is going to become our next root, and then we are left with only L. Now again, we have to make an assumption that L is either be a left child or right child. So let us assume as a right child. So the tree that we get, let me make it here: A, B, C, F, I, J, K, and here if I extend it from D, G, H, L. So this is the tree uh, that we actually come out with these two sequences. Okay, so let's have a look. So this is the actual tree that we are having, and for this tree we have the post order and this the pre-order. And now with the help of these two traversal post and pre, we are trying to get the binary tree. So if you compare the two trees, so you can see that it is actually matching in our case, but there's a possibility that you are going to come out with the solution where this L is maybe a left child, and here this K is going to be a right child. So it is possible to construct a binary tree if it is a full binary, means all the nodes are having the two child, but if the node is having one child, then there is a possibility that we are come out with different structures. So I believe you have understood how to construct a binary tree and what are the limitations when you are going to construct a binary tree using the post order and pre-order. So we cannot guarantee to get a unique tree, but for sure, if we have two sequences which include one in order and other either pre or one in order, other is post order, then we can guarantee to get a unique binary tree. So that's all for this video. Thank you very much.